everyone, my name is Edith and I will be teaching you about the intermediate value theorem today. What is the intermediate value theorem, you ask? Let's take a look at the definition. Suppose that f is continuous on the closed interval AB, and let n be any number between f of A and f of B, where f of A does not equal f of B. Then there exists a number C in open interval A and B, such that f of C equals n. To help you explain further, here are some examples.
Alright, as seen as in example 1, Edith starts out in the beginning of the walkway at point A, and at this point she hasn't moved at all. She's moving at a constant pace, so the distance increases in the same rate. So at point B, she reaches the end of the walkway. So we know that f is continuous because it's a line. And also, since in the beginning she hasn't moved at all, and at the end she's at the last point of the walkway, so the distance is greater than A. So f of A is less than some point f of C in the middle of the walkway, which is less than f of B because that's the end point, which is the furthest distance from the beginning. So we know by IVT there exists an f of C on AB, which she walked through.
Example 2, walking up the stairs with Brenda. As you see in the video, we have an f of A point where she was at 0 height, and then we have an f of B point where she was at the highest point. It says f is continuous on the closed interval A to B, and since f of A is less than f of C, since A is the starting point and she's at 0 height, and f of C is less than f of B, since f of B is the highest point, since when she's at the top, there exists an f of C in which she, at some point, passed through that point when she was climbing up the stairs.
Example 3. Show that there is a root of the equation 4x cubed minus 6x squared plus 3x minus 2 equals 0 between 1 and 2. So first of all, we know f is continuous since f is a polynomial function. So in order to find out if we have a root in the function, we have to find out if f of c equals 0. In order to find this out, we are going to test 2 points. The first one being f of 1. As we see here, f of 1 equals negative 1. Now we're going to test out f of 2. And here we see that f of 2 equals 12. And with this information, we know that f of 1 is less than f of c, which is less than f of 2, f of 1 being negative and f of 12 being positive. So by IVT, there exists a c on the interval 1, 2 such that f of c equals 0.